Let's start with this question too. They are telling us that we estimate the 99 you estimate, okay? You estimate the 99% confidence interval of the mean weight of all bags bought by the restaurant. You are just estimating to see where does the mean weight of all the bags bought by the restaurant fall. So you need the lower limit and the upper limit. When they say you look for the interval or the limit, the confidence limits, you need the lower limit and the upper limit. So here you need to know, am I estimating using t-test or z-test? Use t-test only if the sample size is below 30. If the sample size is 30 or more, then 30 or above, then you use the z-test. What are we given? We are told that a busy restaurant in the center of artisan workshops in Kampala buys fruits in bags towards the festive seasons. In order to ensure quantity of the fruits packed in the bags were accurate, a sample of 360 bags was tested. What comes into your mind here? What comes into your mind? Here you are using automatically what? You're looking at a sample which is above 30. So you automatically use what? Z test. Okay. So we are told that in order to ensure the quantity of the fruits packed in the bags were accurate, a sample of 360 bags was tested and it yielded a mean. It yielded a mean weight of 100. Now it is from the sample where you were in a position to get the mean weight. So this is the sample mean weight of 100 kgs. This is the samples. This is the sample mean. Sample mean, and you have the sample standard deviation. You have the sample standard deviation. So it is a very, very easy number. Very, very easy number. But you find that sometimes it carries 8 marks, 5 marks, 4 marks, depending. Now, always know that as you're dealing with these questions, you may either be dealing with mean, or you may be dealing with proportion. It's something that you need to know, that a question may be taking you to proportion. Finally, you're given the percentages, or you're given mean, okay? So we are going to see, how do you handle a question where you're given proportion in the question? So there you will be looking for the population proportion. You will not be looking for the population mean. Like in this question, we are just trying to estimate where will be our population mean, because we are given a sample mean. Where can we find our population mean? Okay, remember it is from the population where you get the sample. So here you have the sample mean. First of all, in this question, we have the sample size. The sample size as n, and our n is what? 360. We have the sample mean. The sample mean, which is x bar. Sample mean, the standard, the standard sample mean, the standard, or the sign we use. Just a minute, I first get my sign here. This is the sign, sample mean. Sample mean, that is the sign you always use, which is, let me hope now you're seeing the screen. What is the sample mean given in the question? The sample mean given in the question is 100 kgs. 100 kgs. 100 kgs. That is the sample mean. And then we have the sample standard deviation. The sample standard deviation, which is abbreviated as S. The sample standard deviation, which is abbreviated as S. It is from the question, it is what? The sample standard deviation. It is 15, eh? It is 15. It is 15. When you're looking at population size, the sign is capital N. If it is population size, the sign is capital N. Okay, so we are estimating based on the basis. The basis we are using 99%. The basis is 99%. Okay. Now, when you're estimating the population mean, you want to know where does the population mean fall? Where do you find the population mean? In which level, in which interval? What is your population mean? The population mean is denoted as that is the sign of population mean. That is the sign. Now, we are looking for the interval. We are looking for the interval. So when you're looking for the interval, it will be the sample mean. It will be the sample mean minus or plus, minus or plus, minus or plus, Z, the value from the table. So call it Z alpha, the value from the table. I am using Z because the sample size is above 30. Okay. I'm using, so let me put here Z alpha to show you that I'm using Z. So this Z you're seeing here is the value from the table. When you're using Z table, we are going to see how do you get that value from the table. Then times whatever you get, you multiply by the standard error. Times the standard error. Okay, that is the formula. That is the formula. Simple one. How do you get the standard error? Standard error. How do you get the standard error? How do you get the standard error? As you get the standard error when you're using the mean. So here is where the difference will always come when you're using the proportion and when you're using the mean. How do you get standard error? Now, when I'm using mean, when I'm basing on mean, my standard error will be this standard deviation S divided by root n, divided by root n, divided by root n. You get the sample. You get the sample standard deviation divided by root n, which will be equal to standard deviation here. What is our standard deviation? 15. divide by square root of what? N. What is our N? So square root of 360. What do you get? Use your calculator direct and get the answer. What do you get?
0.7906.
0.23 decimal points.
0.791.
All of you, that's what you have?
Yes.
Okay. That is our standard error. That is our standard error. Okay. Then how do we get this value from the table, the Z alpha? How do we get this value from the table? The value, this will be our value from Z table. This will be the value from the from Z table, from Z distribution table. How do we get this? Now, whenever you are dealing with estimation, you will get it was which percentage in this question? What was our percentage, the basis?
99%.
The basis was 99. 99. I remember we be dealing, as I said, we be dealing with level of significance. We don't deal with confidence level. We deal with level of significance, the percentage error. So the percentage error is 1%, which is the same as 0.01. The remaining percentage, because that 99% is the percentage of accuracy, that is the confidence level. That one cannot be the percentage error. How? Okay, so once you have this, because you're dealing with two-tailed, divide this figure by 2. Because of two-tailed, because here we are using what? Just I'm putting this for you to recall. Here we are, but here we are using, let me state it here clearly, but here we are using a two-tailed test. Whenever you're dealing with estimation, just take it from me that whenever you're dealing with estimation, it will always be two-tailed test. Whenever you're dealing with estimation, it will always be two-tailed test. Because you want the lower limit and the upper limit. The lower limit may be negative. You don't, okay, you may find that it's negative, but there is already that assumption that it can be. You don't know exactly the side. So you're dealing with two sides that go. Okay, but here we are using two-tailed tests. And because we are using two-tailed test, we need first to get that 0.1, we divide by 2. What do you get? What do you get?
Zero.
0.05. 0.005.
So that is the value after dividing by 2. If you are using Z test, always listen to what I tell you. It will help you. Now, like here, if you are using Z test, there is another step that you're going to do. Because you want to use the value from the table. This diagram, this diagram you see here, this diagram that you see here, This diagram that you see here. This side alone, from here to infinity, is 0.5, and from here to infinity, right side is also 0.5. And now, after dividing by 2, you are concentrating on one side, okay? You are either concentrating this side or you're concentrating this side, but it is one side, okay? And because you're concentrating on one side, you want to know the exact basis. You want to know the exact basis. What you're going to do for me to get the value from the table, I get that 0.5. I subtract this 0.005. What do I get? I want the probability. Here you are trying to get here, get the probability, that will help you, the probability of Z. This probability will help you to know the value from the table. What is this probability? This is 0. What? 0.4. 0.4 what?
495.
So this is the probability of Z. So the question is, what is Z value? What is the Z value? What is the Z value? The value of Z. What is the value of Z? Value of Z from the table. Here now you're not looking for the probability. Instead, you're looking for the value of Z. This is what we are focusing on to get Z. All right, so how can we get Z from the table? How can we get Z from the table? I am going to use one of the past paper questions. I show you how we can get Z. Which screen are you seeing? Z table is the first table. Are you seeing the table?
Yes.
No, yes.
The first table where you see probability of Z, that is the table. So you want this value that you see inside, these ones that you see inside are probabilities, All these ones you see are probabilities, okay? Now, the Z, the value of Z will be this. We start by reading. Now, okay. Since we have the probability and we are looking for the value of Z that gives us that probability, what we do, we first look for that value. What are we looking for? We are looking for 495 as the probability. Where do we find 495? Where do we find 495? You look at all these values. Where do you find 495? Now, the quick way, you look for where 49 starts from. That is the quick way you can, the easiest way you can get that value. First, know where 49 starts from. 495. Okay, 495. Okay, so you have, like now here you have 493, 494. So you need where you get 495. The starting point where you have 495, are you seeing that it is here? The starting where we have 495. 495 starts from here. 49 starts from here. It starts from here. Okay? So one student can say, I am going to base on this, or I am going to base on this. Because you want only 495. If I base on this 495, 4949. Can you get 495 here? No. When you look at this, you may not get 49 here. 495. And maybe if you round off. So I can get 495 here because if it is 4951, within here I can get 495. So I can use this one as the basis. Don't use this one because now how can you use this one yet you have this? At least start with the first one. Start with this one. So you use this one as your basis, So after knowing that this is where you have 495, then look for the value of Z that gives you this. And what is that value of Z? Using this row, it is 2.5. Are you seeing that, all of you?
Yes, please.
I'm not very fast because it is the first session. Other things I will be very fast. So you first write that 2.5. You first write that. Then which column gives you that point? Here you first write the raw figure, which is 2.5. Then which column gives you this? Which column? You move up. Which column? It is column what? Column 8. Are you seeing that? Column 8. Column 8. So you write 8. You write 8 at the end. You write 8. And that's how we get value of Z from the table. That's how we get value of Z from the table. Okay. Now, once I get the value of Z from the table, I substitute in the formula because we have everything. We have x squared, x that is sample mean. We have value from the table. We have standard error. So you can get the population mean. The easiest way you can say that the lower limit. Now the lower limit will be equal to what is your mean sample is 100. I get 100. I am following the formula. I'm following this formula. Since I'm looking for the lower limit where I have plus or minus, I'm looking for the lower limit. I use minus. Minus. I put here minus, open bracket. What is the value from the table Z? 2.58. Then times what is the standard error? Because the formula is saying after writing the value from the table multiplied by standard error. This is our standard. This is our standard error. This is our standard error.
So
What?
That alpha doesn't mean anything?
Pardon?
The alpha that you put on Z value doesn't mean
The alpha is like the basis, the percentage you based on. This one. It is this one. The alpha can be like this 0.005. You get it? So that one for you, I simply know that that is just like the value of Z. Is it okay? So this is alpha, should not confuse you. It is just the value of Z from the table. Value of Z from the table. What do you get? Guys, put some speed. Put some speed. Just put everything on your calculator. 100 minus open brackets 2.58 times 0.791. What do you close bracket? What do you get?
It is 97.
97, 97.
Point 97.959.
Remember, these are kgs. So this is approximately equal to what? So you can first write this figure, then you say approximately equal to 98 kgs. But first write this, First write this. Okay? That is lower limit. Then what about upper limit? Upper limit. Now where you have a plus, rather where you have a minus, put a plus. Other things remain the same. So my upper limit will be, where you have minus, I put a plus. So it will be, tell me 100 plus, open bracket, 2.58 times 0.791, close bracket, equal sign. What do you get?
102.
102,
0.04.
0.04 kgs. These are kgs, which is approximately equal to 102 kgs. So you have, you can say therefore, the population mean. Therefore, the population mean. Mean interval. Therefore, the population mean is between between 9 this one kgs and 100 kgs. Or other people, how they do it is that they can say 98 kgs, then less or equal to, when you meet that kind of write up, don't less or equal to new, we put this, then less or equal to 102. So when you meet that kind of write up, don't be confused. It simply means that if you want mean, if you want the population mean is, it is just from 98 to 102. That's where you can get your population mean. In between there, in between there. Okay? And you're done with the number. We are done with a number. We are done with that number. We are done with that number. Is it hard? We are done with that number. Don't put it in your mind that it is hard. Even if you say that it looks to be hard, don't put it in your mind that it is hard. No. So you're going to do this in your free time. I'm giving you assignment. You're going to do this part B, where you are testing at 90, 95. So when you're testing at 95, that is 0. What? That is 5%. Divide it by 2. After getting the answer, get 0.5 minus the other. The sample size is 30. Here the sample size is 30. So you are still using z-test. You have the average height, that is sample mean. You have the sample standard deviation. So you can answer this. You answer this in your free time using z-test, because the sample is 30. You can use z-test if the sample is 30 or above, 30, 31 and above, like that. You can use t-test when the sample is below 30. Okay. Now, I want you check May 2025, May 2025 paper, May 2025 paper. Which screen are you seeing? Which screen are you seeing? Are you seeing the May paper? Are you seeing question 3?
Yes.
Okay, so that is May 2025. May 2025. So you have the price index question. Then you have these 5 marks, screen marks, 5 marks. They are telling you that on the basis of the sample above, calculate the 95% confidence limits. So you want the upper limit and the lower limit for the mean life of the tomatoes. What are you given? The tomatoes dealers at an outlet in Nakaseke Market claims that his tomatoes take long before rotting. A sample of 100 tomatoes. What comes into your mind immediately? A sample of 100 tomatoes, what comes into your mind? You're using Z-test or T-test?
Z-test.
We are using Z-test. We are tested and the results obtained from the samples where you have the mean of 97.1 hours and standard deviation of 6.6 hours. Can you fail this now? Some of you may be thinking that what we are discussing cannot be examined. Eh? You have those 5 marks. You score 5, you're left with 45. Guys, all you need is 50 in these professional papers. All you need is 50 and life moves on. You score these 5, you're left with 45. Seize other questions and see how you can raise those 45. So any issue on this? Are you seeing any issue on this now? Same steps, same steps, same steps without changing anything, without changing anything. Just that here, here what you have, let me just first, let me copy. Without, this is May 2025, question 3. So if I copy and paste here, I just change. Sample size in this question is what? 100. Are you seeing the screen? Then sample mean from this question, what is sample mean? The sample mean is now whenever you see a like this, you always need to know you can round off to one decimal point on your final answer. So the sample mean is 97.1. Then sample standard deviation. The standard deviation given 6.6. What else do you need? The basis is 95%. That is your basis. These are hours. Okay, so here you have the basis as 95, not 99. The formula remain the same, just that where we have 15, we put what? 6.6. Then where we have n, we are putting what? 100 because the sample is 100. What do you get? Put some speed, put some speed, put some speed.
0.66.
0.66 only. Round off points. Okay. So now after getting standard error, what else do you need? You need the Z value, the Z from the table. But we are testing at what? This is not 1. We are testing at what? 100 minus 95, we are testing at 5%. So that is 0.05. As I said, the estimation, with estimation, you always use two-tailed test. So get that 0.05 divided by 2. What do you get here? What do you get? That is 0.25. Have you confirmed? Eh? So when you get 0.5 minus 0.25, what do you get?
0.475.
0.475. So we go to the table. We go to the table and see. We go to the
Excuse me.
table and see.
Excuse
Yes,
me,
please.
Abel. I thought
Yes, please.
for this, I thought for that step, you look at the level of significance that you have. Is this still, because at first
Where? Which step?
we had 1. On this step where you're getting the probability. At first we had 1, and here we are having
Which
5,
one?
but I'm seeing you are still using 0.5. Here we have 5.
Here we have 5.
5%.
Yes. Yes, which is 0.0.
At first we had 5.
At first we had 1 because it was 99. You get? Now
Yes.
it is 95, which and the level of significance is 5, the percentage error. So after that,
Yes.
After that because you'll be using two-tailed test, you get this figure divided by 2. You get this, isn't it?
Yes.
So we get that 0.5 minus what you have here. So we have 0.475. We go to our table. We go to our table and see. I believe now you are experts. I want you tell me where do you have, so I can remove these. I can remove these ones. Have you observed where you have 475? Someone tell me, have you observed where we have 475, 475, 475. Are you seeing that? Where 475 starts from? Where 475 starts from? Are you seeing that? Have you seen that?
There is that one on the log 1.9, which is
Are you seeing
475.
this? You need to be very fast because now when you just keep on rotating, maybe if you don't have what to do in an exam, and you are using the table to waste time. So you have, actually it is there direct. It is here. It is here. It is here. 47. Let me open my pencil is given here. So you write Z as 1.9 Then which column gives you 475? Which column gives you 475? Column what? Column 6, isn't it? So column 6 is the one that gives us 475. Okay, so that will be the value of Z. 475. We are saying that it is 1.96. You first write the row which is 1.9, then write the column. So that is the value of Z. After getting the value of Z, our sample mean is 90 what? Our sample mean is
97.1.
97.1. That is our sample mean minus the value from the table which we have. The value from the table which we have, times the standard error which we have as well. Here it will be 97.1 plus, because you're looking at upper limit. So that's how you will handle. That's how you will handle this one. You remove, they are in hours. The figures you get are in hours, not kgs. The figures you get will be in hours. Any question? Any question? I'm done with this question. I'm done with that number. I'm done with this part. I'm done with this part. What do you get here? What do you get here? The figures will be in hours. The figures will be in hours. You round off to 1 decimal point because the sample mean and the standard deviation were in 1 decimal point. Okay. And that's all, guys. You have your. What I like with these questions, you don't take a lot of time. You don't take a lot of time to answer. Those 5 minutes, you can 5 marks, you can score them in just 5 minutes. Or even less, because you've been, and even when you are in an exam, when you have been practicing, and you know that your basis is 95%, automatically you don't need to go back to the table. You'll be knowing it is 1.9, the value from the table. You'll be knowing that it is 1.96. You don't need to go back to the table. You save that time. If you are dealing with 99%, you'll be knowing that the value from the table is what? If you have been practicing, the examiner has given you 99%, you'll be knowing the value from the table is 2.58. Okay? So these are things that are really very easy. Okay, we are done with this. We are done with the Z test. You guys, you do this. Let's stop here so that you can master what you have discussed. But do this part B. Already this is 95%. Now you know the value from the table. So you do this part B. Then also you do this. You have good questions to do. You do this as well. The sample size is 1,000. You have the mean as this and the standard deviation as this. Testing at 95. Do that question as well. Time yourself. We are going to look at t-test. How we can use t-test. This one is t-test because the sample is what? When you look at the sample size, the sample is what? 10 pieces, isn't it? So this is t-test. So we are going to look at how we can use t-test. But if you are okay, we can use 5 minutes to do this. If you are still okay, because I just inserting the figures. So when we are using t-test, using t-test, using t-test, here our sample size, our n is 10. Our n is 10. Our n is 10. Oh, we start from there, guys. How do you see? You may be tired. I don't want to, because I may assume you are understanding. We start from there next time.
Let's proceed.
Yes.
Eh? We proceed, eh?
We don't have
Okay.
time.
Sample size is 10. Our sample size is 10. Then we have mean. What is our mean? Sample mean. Sample mean from this question is what? Sample mean is what? When you look at our sample mean from this question, our sample mean is 69.1. That is sample mean. Then is sample standard deviation. Sample standard deviation. Sample standard deviation. We take square root of variance. Square root of variance. We are given variance, so take square root of that variance. Take square root of that variance. And the variance given is 1.58. 1.5. This is 1.58. What do you get? Put some speed, guys. Put some speed.
1.256.
1.256. That is standard deviation. So after getting that, you are going to say that your population mean. Your population mean. You're just fixing in this formula. Your population mean. We have our formula here. This formula here. But where you have Z, you put T. Where you have Z, you are putting T. Because you'll be getting the value from the T table. So where you have Z, put T. Other things remain the same. So what is standard error? The same way. Standard error, we are getting standard deviation over root 2 over root n. Standard deviation over root 2. Standard deviation over root n. Standard deviation over root 2 n. What do you get? You have your standard deviation as 1.256 divided by root n. What is our n? Root 10. That is root 10. What do you get on your calculator?
0.397.
0.397, 3 decimal points. That is our standard error. We have our standard error now. How do we get the T from the table? The value of T from the table. Now this is where the difference is. Remember, the level of significance in this question, the level of significance from this question is what? What is the percentage?
5%.
It was given 5%, 5%, which is the same as 0.05. But this is estimation. As long as you are dealing with estimation, here you must apply two-tailed two-tailed test. As long as you are dealing with estimation, always apply two-tailed. As long as you're dealing with estimation, always apply two-tailed test. Two-tailed test means what? Simply get this 0.05 divided by 2. What do you get? That is 0.025. Now, with t-test, stop here. Don't get that 0.5 minus this. No. Please note the difference. With t-test, after dividing by 2, stop there. Stop there. Then go to your t-table and get the value. Sorry, before you go to the t-table, for t-table, you need v. V will be equal to n minus 1. What is our n? N is 10 minus 1, which is 9. So go to your table and get the value of t from the table, which is equal to what? The value of t from the table, from t table. So we go to our t table. Let me open the question, past paper question, the last that. So the t table is the first table is z table. So we go to the t table. This is the t distribution table. Are you seeing my screen? Now you have v. You have v as 9. You have v as 9. Stand where you have 9. This is 9. Then you have the basis, the probability. You have the probability as 0. What? 0. It was 0. What? 25?
0.025.
0.025. It is here. Okay. So you read the meeting point. The meeting point will be the value of t. This one. This one, 2.262. That is the value of t. 2.262. That is the value of t from the table. 2.262. That is the value of t from the table. And that's all. After getting the value from the table, get the lower limit, and the upper limit. As simple as that. As simple as that. So you're substituting in your formula. Like the way we did this, like the way we are doing this. Just that here, our mean, with this question, our mean is what? Our mean is 69.1. That was our mean. Yes, our mean was 69.1. Then the value of t from the table is 2.262 times the standard error. Our standard error is what? Our standard error is 0.397. That is our standard error. Then you also get the upper limit. The upper limit. Here you add. That's how you would handle. That's how you use your Z, rather your t-test to estimate. Is that hard? Have you noted where the difference is? The difference is here. Once you divide by 2, stop there. Also look for V. Because when you're using a t-table, you need V. I think that's all, guys. I think that's all. That's all. Any question on t-test?
When is the one-tailed test used?
The one-tailed test will apply when we are testing, not when we are estimating. When we are testing somewhere, we are going to be using one-tailed test in some scenarios, especially when we have a side, when the examiner has specified the side. Maybe the examiner has said has shown something like less than or greater than, where you know the side, like he has clearly stated that you have a greater than figure or the less than figure. So you are going to see that, because when he specifies that, let's say you're dealing with a greater than, it means that you expect all the values to be in one direction. In one direction, the right side. Then if he specifies that maybe you need to test and the figure is less than this, it means that you are dealing with left side, one direction. Where you have one direction, you apply one-tailed test, because you are specifically dealing with one direction. But now in these estimations, you don't know which direction. You don't know which direction. Is it right or left? You don't know which direction. So you have to apply a two-tailed test. Two-tailed test. So that it can help you to know the focus, one focus. After applying the two-tailed test, that two-tailed test helps you to know the focus. The focus, the basis you should use to get the value from the table. Okay, so that's all. That's all with t-test and the z-test. But that doesn't mean that we are done. That one alone doesn't mean that we are done with this part. We still have a lot to discuss for sure. We still have a lot to discuss, because there is also, they have never examined this. There is a scenario where you're going to find that you have more than one sample. You have more than one mean. How do you handle? If you have more than one mean and more than one sample, how do you handle? How do you get that confidence limit? We are going to see that. Then we are going to see in a scenario where you are given now proportions. You see this part C? When you look at this part C, you are testing at 95%, but you're given percentages, 35%, rather 37%. How do you handle? If you're dealing with proportion, here you are looking for the proportion of fruit drinkers, not the mean. You are looking for the proportion. Okay, so in what percentage can we find the fruit drinkers, not the mean? So we are going, next time it's where we are going to start from. We are going to start from this one. As we drive to testing. So let's pause now. Let's pause here. Please, you do these questions that I have shown you. A question that requires testing, they will be saying test. Test. Here you are not looking for the estimation, you are testing. You are testing the belief. Test. You see that? Test, test, test. Using this, determine whether we can conclude that. You can only conclude when you test. You get? So we are going to be testing, testing, testing. Okay. So let's stop here. Let's stop here. Let's stop here. We meet next time, guys.